So welcome again. As Margarita already mentioned, the topic of today is to discuss about the agroecological living labs in Africa in the different sister projects. And she already posed these questions. So what is it, a living lab, and an example? What are the benefits and what are the major challenges? And, our practice project, I introduced it to the others a couple of months ago. It's on potentials of agroecological practice in East Africa with a clear focus on a circular water, energy, nutrient system. And so the overarching aim is to develop decision-making tools with the help of these 3 living labs we are planning. And we are already ongoing with the setup of 3 different living labs. And so I don't think that I have to do too much to give you too much into the details. So we are in total 16 partners, and the focus is area-wise. It's Uganda, Kenya, and Tanzania in East Africa. In all of these 3 countries, we are just about to set up living labs. And so I could, if you allow me, get started. I would like to introduce just the one in Kenya, and then to give the floor to others. So so we have co-creation activities. I think we can discuss about these details later on. And as I mentioned, we have 3. We are planning with 3 living labs with different addressing different varieties of what is important for us. It's a combination of aquaculture and agriculture. These are the keywords. So integrated aquaculture, fish farming, and agriculture. So, and the first living lab in Kenya, in Kisumu at the Lake Victoria, it's what is a salient feature of this living lab is we are using treated wastewater. So there is a lack of fresh water in this near Kisumu. And therefore, we are tapping wastewater from a waste pond, pass it through a filter. It's called a membrane bioreactor. So it's a advanced wastewater treatment technology. And the water, so quality, the effluent is good enough to use it for fish farming and to use it for irrigation as well. So these are the 2 things we are looking into. And in addition, we also use the water from the fish tanks, which is rich in nutrients, for irrigation. So we want to compare the just MBR treated water and the water with the nutrients. We have a pretty good field of experiment where we can run all this. And so number 1, the membrane bioreactor. So it's almost done. % of the work is done. We are optimistic to get it commissioned started by April, mid and end of April. This is the aim. And so I think there's no time for details, but the most salient feature is it's working like a sewage treatment plant. However, the water is not settled, but it's passed through a filter, retaining germs, particulates, and so on. And it's well suited for definitely not for drinking purpose, but for irrigation and fish farming. And in addition, we have also a activated carbon filter in order to remove a majority of the so-called micropollutants, which may pose some trouble. So this is the MBR, the element producing the water. And the site in Kisumu is and makes use of an existing site. We had an upfront EU project, Wikinaqua, where we set up already a small MPR and a fish farming, fingerling production site. And so we are finally extending what is already existing in the practice with a larger and extending also the irrigation part, the agriculture part. This is on top. You could see on the left side. Can I laser pointer? Yeah, okay. On the top, you could see this was the existing one. This is a fingerling, small fish production, which was set up and operated in the previous project. And now we want to grow the small fish in the practice with these tanks, very simple and very cheap tanks to grow out tilapia to larger fish. This is the aim of the practice. And this water, which is used in these tanks, can be drained out for irrigation purposes to the field. And this is how the field looks like. You see on the left, there's the waste pond, and we have a pretty large, something like an acre. And so this is it's not yet prepared. It needs to be prepared, and we want to grow vegetable and so on. And what is also important, we want to make use of soil sensors like this, and also satellite images in order to improve and optimize the crop growing. And in addition, we also have a small field to grow black soldier flies. Maybe you've heard about this. This is very popular now in Africa. The larva is is rich in proteins, and it's a very good food for animals, all kind of. And we want to feed the fish with this with the larva, with this protein-rich meat, and we want to grow these black soldier flies also on the ground. Yeah, okay, so this was a quick overview on one of our living labs. And so what is important in my view is and it's also a salient feature of the agroecological living lab, that we involve the practitioners. So it's an open area. We receive many stakeholders, students, and so on. We can show them around, and we can work together in research. It's not like an ivory tower in a university. We can together bring in students, stakeholders, and discuss. And this is also what we did, and this is a good thing. We also had the upfront Wikinaqua project, which started in 2016. So since 2016, we have been working in this field and received several thousand of visitors now, and we can continue with this. And we can easily exchange our knowledge, bring the knowledge to the outside population, and in a participatory research approach. And so I'm very, very, very optimistic that this is the right way to bring it further. And by the way, we also have now a spin-off company which was set up by some former students in fish farming, and they also started on the site, and they want to develop further and to bring this on a more in a marketing way with a business plan. With now they have like 10 people, and to bring it out and to develop something, this is also very important to have a company or a spin-off or something that it's continuing even at the end of the project. Okay, now I can stop here, and I want to give, I'm curious about our sister projects, about the living labs, and what is your experiences in this field?
Yes, maybe we can leave the floor to Miguel Ribeiro from CIRAWA.
Thanks for inviting us. Hello, Sylvia. Nice to see you. Yeah, in the description you said there was not going to be any PowerPoints, but I prepared a couple of slides also, like Professor Jan. So maybe I can share my screen a little bit so that I can give you all a context on what we have been working previously to the CIRAWA project. So ADPM has been working in Cape Verde for around 25 years now. And for the last 5 years, we have been working more into agricultural production and agroecology, agroecological practices. So I have a small presentation here prepared. Maybe I can share my screen. Agroecological Living Labs. This is basically a case study from Cape Verde. What I'm going to present to you is the work developed in previous projects, but that we will continue to work on with CIRAWA, and we will have a novel approach in another island. So just to give you a small context. So Cape Verde is an archipelago country made up of 10 islands off the coast of Mauritania and Senegal. As you can see in the map, it's within the Sahelian ribbon, let's call it. So it comes within this hot semi-arid climate with a temperature range from 20 to 30 degrees, pretty much temperate climate related to the oceanic currents that come from the Canary Islands across the Atlantic coast of Africa. But however, it has an average year rainfall of 205 millimeters. That actually, it's pretty sparse and erratic between islands. So, and also between years. So you can have up to 3 or 4 years in which practically there is no rain whatsoever. And when rain comes, it comes in a very short time. It floods everything. It creates a series of problems related to erosion, flooding within the villages, and all of that kind of situations. So in terms of the agricultural landscape, what we're talking about in Cape Verde is really a traditional rain-fed smallholder agricultural systems. So very low machinery, very low technical inputs. A couple of staple crops, sweet potato, English potato, maize, and beans are the main crops, with some cassava always also being grown, and also some sugarcane. However, this is a land that, as you can see, in a 10-island archipelago, volcanic archipelago, it has less than 10% of the total country area is arable land, within a very heterogeneous orography. So we are working on Saint Antão, which is, can you see my cursor?
Yeah.
Yes. Yeah. So Saint Antão is the westernmost island here. So this is where I've been working for the longest time. And this is a very small island, but has an elevation of almost 2,000 meters. So it's a very rugged terrain, as you can see in these pictures. Most of farming is made on these how do you call it in English? These sucalcos, so these little terraces. Yeah, and we are going to start working within the CIRAWA project here on this island. So this is the island of Maio. We will get to Maio in a bit. As I was saying, traditional smallholder rain-fed agriculture, little arable land, little rain, okay, very, very low surface water, and also some problems with salinization of the phreatic water, okay? So after the rains, you will have some sweet water that can be brought up from the boreholes. However, during the year, all of that water will start to become more saline, and it creates serious problems with the soil acidification and salinization. Okay, I moved this. Let me see. Okay. So the government in general has some public investment policies on irrigation infrastructure. So tanks, check dams, and drip irrigation equipment that has some mechanisms to make it more available to farmers. However, there is a very, very low private initiative. So farmers are, as I said, subsistence farmers. They have a very low economical capacity. So there is this very big gap between what the state can do and what the farmers can actually do. These are systems that are characterized by low productivity with a a great lack of labor force and machinery. So these islands are very, very prone to immigration. No young people, they just move away to other islands or to other countries in the world, from Europe to America. And very low use of machinery. Okay, so people are not used to having tractors, not even cultivators or anything like that. People work with their hands, shovels, and they even carry all their produce still in either pickup trucks in the best scenario or donkeys, with very, very sparse technical know-how, even within the state officials and the delegates from the Ministry of Agriculture. So I just want to give you this introduction because I believe that a living lab needs to work both on the technical side and on the social side. Okay, so this is what the approach that we will try to develop here. So basically, to present to you the work that we have been doing in Sant Antão. Sant Antão, as you can see there in the map, is that island there in yellow. We developed 3 agroforestry demonstration sites, what we can call our living labs, supported by 3 plant nurseries, 1 on each of these sites. So basically, what we are doing is working with our horticultural and tree crop diversity. So to make people aware that in a growing season, they can grow a lot more than what they traditionally grow. Okay, drip irrigation techniques, forage production and processing. This is something very important in Cape Verde because people raise a lot of goats and they produce cheese from the milk. However, in this arid environments, forage is not really available for most of the year. So the cattle just pretty much, cattle and goats and sheep, they pretty much just roam around the islands, and they affect severely the regeneration of the pastures, of the few of the trees that can actually grow here. And we have been working both with cattle management techniques, so grazing management, and also forage production and forage processing. So we developed this prototype of a mix with the sugarcane residues, moringa leaves, and also tree lucerne. I don't know how do you say this? Basically leguminous trees, perennial leguminous trees that we can mix with the sugarcane to make pellets to feed the cattle. Okay, so that farmers can have perennial cultures that can be used and harvested regularly to make produce for their animals during the dry season. Also working with my biomass production infrastructure, so basically wind barriers and support species that we can chip and use as mulch or to compost. Related to all of this, we have the consequent ecosystem support services. So these are very windy islands with a lot of erosion. All of the plots are very exposed to the environment. So as you can see in the image on the right, this is one of our experimental sites. We started growing tree lines and support species so that we can make horticulture in the middle, so saving water and avoiding a lot of the problems related to the wind action. Also, pollinator promotion, integrated pest management, that all come out of this diversity. But also important is the rural extension and educational activities that we develop within these test sites. Okay, so as you can see in the picture in the middle, that's one example of one of the many visits of schools that we have from the island. Going there to visit, have environmental education programs. We also work with techniques from from the Ministry of Agriculture, from other NGOs, farmers that can actually they can see the examples on these experimental sites, and they can transfer it through their extension work to the farmers from the communities in which they work in. So this is what we've been doing in Sant Antão. These are systems that are going to their 5th year of implementation. We are getting some very interesting results in terms of organic matter content in the soil, in terms of water retention capacity, and also when you work with trees and perennials, all of the benefits, they start coming only after 4, 5, 6 years. So we are getting to the good part now. in CIRAWA, we are trying to expand this idea and this approach to the island of Maio, okay? The island of Maio has some different challenges, and we will create a new demonstration site, okay? We have been preparing the plot still. There are no actually interesting pictures of that, it's just barren land. So I just put some examples of what we will be doing there. So Maio Island has a particular climatic context. It's a very plain island, so the highest point is like 400 meters elevation. It's been dominated by Prosopis juliflora, so this is a very invasive leguminous species that was integrated on the 20th century in several parts of the world in reforestation efforts on desert areas. However, it becomes very, very dominant and very, very difficult to manage. However, it pretty much is the only tree that can photosynthesize on that island and that accumulates carbon. So we will try to use this as a tool on our side. And basically in Maio, what we will be working on will be biointensive horticulture techniques. So it is a very, very dry island. The aquifers, they become saline very, very early on in the season. And so people have to do the most with the small areas that they can farm with. So biointensive horticulture techniques are pretty much what they need to do, okay? Small, diverse cropping, a lot of organic matter on that small space, because again, they don't have a lot of technology there. They don't have any tractors. They don't have any rotavators. So we'll have to do it small scale, very intensive production. We will also work with the farmer managed natural regeneration so that we can try and get this idea through that with the work of farmers as, you know, the landscape managers, let's call it, they can actually change the biotope and the landscape in terms of vegetable diversity and tree crops diversity. Rain-fed farming improvements. So rain-fed farming is very, very, very important in Maio, as I said, because of the difficulty of access to water. So we will try and work with farmers on techniques that can basically retain water for longer on the soil, make the crop production more efficient in a rain-fed scenario. Also soil microbiota promotion, working with liquid fertilizers, bioactivators, and biochar. Biochar is a very interesting approach to be developed in Maio Island. In the picture in the middle, what you can see is a charcoal production oven. There are a lot of them in Maio Island. Maio Island has a 3,500-acre forested area, basically dominated by this Prosopis tree, and they use it to produce charcoal that they bag it up and sell to the other islands. What's left from this production is a very, very fine charcoal powder that we will try to work as a soil work with as a soil amendment and as a support for all of these liquid fertilizers to be applied within the soil. Because when you use water, if water is scarce, when you use it in a land that's not actually very fertile, you're pretty much wasting that water. So we will need to use the water as a transport for nutrients, and we'll try to use the biochar to retain that nutrient capacity and that fertility within the soil. And also working again with accessible technology, so trying to work with low tunnels to avoid wind damage. Also, they have a very serious problem with locust infestation that come from the mainland Africa. So they will need to start thinking about protected cultures with low tunnels, greenhouses, something like that. And also rotavators, wood chippers, having people understand the advantages that they can use with just switching between their traditional hoe practices to working with rotavators to make their economical profitability a little bit more interesting. And also, again, rural extension and educational activities. We will stay with that approach. We will bring schools, we will bring technicians. And yeah, this is pretty much what I had to present to you of what we are going to work on in Cape Verde. Thank you.
Thank you very much. Very interesting. One question. What do you see based on your experience so far? What are the main benefits and the main challenges? So what do you think? Can you give us
Yeah, so from the example that the work that we developed on Sant Antão, we can see a lot of replicators adopting the practices that we did use on the experimental side. So that one of the experimental sites in Sant Antão is within a compound farming area. So we are using one of the parcels there, however, one of the plots. However, there are a lot of similar plots around the area with neighbor farmers. And from the beginning of when we started to implement that the experimental side, we brought in a lot of different species. We started putting trees within the field, and people looked at it like, "What are these guys doing? Like, it doesn't make much sense." However, 5 years have passed, and you see a lot of farmers, especially with tree integration and mulching. So they clearly saw the benefits of the water retention capacity of having all of the soil covered in that windy environment, and the effect of the wind barriers on the small plots. So the main benefits of this kind of approach is showing people, like because when we have a living lab, we are not usually so constrained on the economical side of the agricultural production. So it is a demonstration site. Usually these living labs are funded by different projects or different institutions. So we have this experimental freedom to do a little bit of unusual practices, and people actually relate a lot to that. So when they start seeing results, and this is the important part of a living lab, more than just showing like you should do this and this, we need to have the living lab working for enough time so that people can actually see the results of that, and only when they see the results they can adopt the practices. So in Sant Antão, we really saw a difference, and you can see it when you visit the site. A lot of a lot of the farmers have already planted coconuts and papayas and sugarcane on the sides of the parcels, so they are not getting rid of the dry hay and burning it, or just throwing it away. They are putting on top of the raised beds. So as an example, it is very useful, and also for the capacitation of techniques that are working on the area. So again, not only to farmers, but to extension workers, particularly for the Ministry of Agriculture. We have a lot of different workshops in different contexts, so for people to go there, and they can actually they have a little bit more of technical knowledge and expertise, so they can actually question us, and we can have these kind of debates on what is the best approach. Can people replicate this? Is this economically feasible or not? And all of this will go and spread out, from the living lab through the extension offices and to the different communities. And we actually see that all across the island, there are a lot of people adopting all these different practices. And one thing that I think it made had a lot of success, and it brings people, is that on each of the experimental sites, we have a nursery, a plant nursery. And that plant nursery is not only for the living lab, but it's to sell plants to other farmers. So people know already that within the island, they can go to these 3 different nurseries, whether they understand that it is a living lab or it is a demonstration site. What they know is that on those spots, they have papayas, they have guava, they have coconut, they have a lot of different tree and plant species that farmers can go there and they can get them at a cheaper price than, because in Cape Verde, as you can imagine, a 10-island archipelago, it's very difficult to get a lot of plant materials. There are not so many nurseries. When you have the bigger nurseries, they are in Santiago, which is the capital, let's call it the capital island, the main island, but it's very far away from Sant Antão. You have to go by plane. So you have to really create a local resilience and a local ability for people to access this kind of material, either in plants, on production factors, materials. And within the projects, we've been able to bring all of this stuff to the island and create this dynamism where people know that they can get this kind of material from our spots. So I think these are the greatest benefits on having this kind of approach. First, showcasing good practices, educating technical staff, and having material and production factors available to people, particularly in the case of Cape Verde. Yeah.
And how about challenges? What do you see? What are the main challenges?
Challenges as I said, in Cape Verde, agricultural practices are very, very, very traditional in the sense that there are a lot of farmers, and sometimes I have I have troubles calling them farmers. Actually, people, they do agriculture because they always did it. You know, people, when it rains, people go to the terraces. They put all the corn seeds and they do it in a traditional way, but they don't really prepare it. They don't look at it as an economical activity. So it's a subsistence activity, but like if it produces corn that year, okay, that's very good. If it doesn't, okay, we will try next year. So it's not really something that this is like the general picture. Of course, you have farm businesses, you have production there, of course, but within our with our approach, we are not really going in that sense, because within this agroecology umbrella, what we are trying to build is from the bottom up, trying to make traditional practices more productive, more economically feasible, and most of the challenges are apart from the logistics of all of this, particularly in Cape Verde. So it's very difficult to get materials, to get machines, to get plants, even to move people around is very, very complicated. But the cultural aspect is it's not easy to deal with. Santo Antão is a different scenario than the case of Maio. Okay, Santo Antão, it's a much more, I would say, urban island. Okay, so much more cosmopolitan. You have a different kind of social dynamics there. In Maio, so that you can see, in Maio there are 4,000 to 5,000 inhabitants there. And most of them are really, really poor, and they cannot even think that their livelihoods can become something better than what they have. Okay, they're pretty much okay with what they have, and they are very hard to communicate all of these changes. So they're very impervious to change and to different approaches. So maybe this is what I consider the biggest challenge, is trying to explain people that don't have any knowledge about soil fertility. They don't have any knowledge about ecosystem services, about any of these that we are researchers, we are technicals, so we know this very easily. We can talk in this language. However, people in the field, they don't understand that. They don't understand why should they leave the straw on top of the beds if all their lives they cleaned everything and they left all of the soil exposed and all of that. So little by little, and against the importance of having long-term living labs, and living labs that can actually show results more than practices, show results. When they see that, okay, these guys' sweet potatoes are bigger, heavier, and healthier than mine, maybe it's because they put the straw on top of them, So yeah, this would be the major challenges that I would identify.
Yeah, this is in line with our experiences. Yeah, to change the tradition and not to push them from outside, but teach them by showing the good results. I think this is a good, very good statement. Yeah. Yeah. So we can pass the floor to, or are there other questions or remarks on this? But I think we are now, getting to the core of what, and I guess that other projects have made the same experiences, or who would like to, present something.
Maybe we can leave the floor to NATAE project, Professor Van Deven.
Okay, fine, thank you. I'll explain a bit about our project, and also Marilena, she's a PhD in our project is present, and Melanie is the coordinator of the whole project. And it's a European Union project, and I'm the work package leader of the Living Lab work package. We've made our approach is a little bit different from what I heard in the previous presentations, but I think that's only nice to compare and to have a look on that. We made a definition of an agroecology living lab as NATAE, and I'll just read it out to you to give a bit of a background. And we defined it as a self-organized place of structural exchange between food system actors on the identification and testing of combinations of agroecological practices while working towards a joint vision for an implementation of an agroecological transition. So it's quite broad. It focuses on the primary production, the farmers, but also other actors in the food chain. So it has both a social and a geographical component. And we work with different stakeholder groups. And I also have a few slides, only very few, which I can share with you, I think. So it's this is a short introduction. The project is not 5 years, something like that, but we started December 2022. So we're now almost, well, let's say 1 year and 4 months on our way. And I think, we are with quite a number of partners in this project. It's, I think, it's 23 partners included. It's a European Union project. And this is the living labs we have. We have 6 living labs, and they are indicated here in brown, and they cover the whole of North Africa, more or less. The countries are listed here. It's in Mauritania, Morocco. In Morocco, we have 2. Algeria, Tunisia, and Egypt. And I'll show you a little bit more about what we do in Morocco in Boulma, because we've been working there quite intensively during the past months. And the main products, they differ. And the other difference between the living labs is that they are about different farming systems. So we have peri-urban agriculture, mountainous agriculture, oasis, cereal plains, and irrigated plains. So these are different agricultural systems, agricultural ecologies also to work in. And each of them has a different spot in North Africa. And each, because they're so different, they also have their different challenges that need to be worked on. And in each country, we have our partners are living in these countries, working in these countries, have experience with these systems. We have the living labs to go more into the basics and the development of these agroecological practices. And then we have replication labs, and these are in green on the map. And they are, because of the living labs, we do more detailed research and development of the system together with the stakeholders. And in the replication labs, we would like to see if we can test what we learned, if that can also be applied without all the details that we have in the living lab. So can it be expanded to other areas, but with similar systems? So the replication labs are in similar agroecosystems, but different regions, and see if the agroecological practices developed in the living labs can also be applied to the replication labs. And now I'll just give a short idea about what we did in Morocco in the mountainous area. This first picture here is an overview of the area, and our approach is that we first had a kind of territorial diagnosis. So what's going on in these areas of the living labs? We did it for each specific living lab, and it's not me as work, but all our other partners in the project, so the local partners, they really played a very important role there. Then based on that, there were some challenges and issues defined for each living lab. And for instance, in Skora here, maybe I should go one back in Bulman, the main products are olives, vegetables, aromatic and medicinal plants. And the specific challenge for this living lab is women employment and cooperative empowerment. So that's what the specific challenge was formulated by the people working in that region. So we've developed a whole methodology on how do we approach these type of things. And what we try to do is develop a general methodology to approach a methodological approach for this living labs. And then for each living lab, some specific issues will come up, and yeah, it needs to be adapted, of course. We said, well, we want to work with the people there. So here you see a focus group discussion. So to get the idea of what is happening, what do people need, what are the problems. We had focus group discussions there. The first focus group discussion you see here was with only men, but we also have a focus group discussion with women, because this living lab is specifically focusing also on the role of women in the area, in the agriculture. And based on the focus group discussions, agroecological practices were identified that people, these farmers, because these are all farmers, women and men farmers, what they think would be the main agroecological practices to focus on that could help them improve their systems. And then these agroecological practices were taken to the representative board, because in each living lab we formed a representative board. And these are people, these are also farmers, but also other stakeholders in the region and people in the food value chain. And so we work on the context-specific agroecological practices with a series of farmer and stakeholder exchanges. And based on the results of these focus group discussions, we will start working on those agroecological practices that are identified here. And the 5 agroecological practices that emerged in Skora are the association of olive trees and aromatic and medicinal plants. So to combine that, the women now have often sites, work on the sides of the fields of the men and have some of these aromatic and medicinal plants, but they really want to expand that, and that could be in association with olive trees. So that's one thing that can be pursued. The other one is surface irrigation and improvement options of surface irrigation compared to what's there now. Another one is drip irrigation. Of course, that's a step further. But also the use of animal manure, how to use it, compost it, how much. So that's also an agroecological practice that comes to the fore. And the use of shredded tree pruning residues, because these olive trees are pruned, and there's a lot of pruning residues becoming available, and how can that be used in the systems. And we really focus on a systems approach, so looking at the effects in the whole farming system. So this is in short what we've been doing so far in Skora, and we will have a meeting in Tunis in May, and to also discuss with other living labs what they are doing, and if they can see what we can learn from all the living labs together, discuss all these agroecological practices, and so on. And in our whole project, this will also be the data, because we collect data on these farms, that will also be used in a modeling chain, and quite a large model that is fed with the data from the current system, also from the new agroecological practices and how they perform in a system calculated with the model, and then see what comes out as being very useful agroecological practices and combinations of agroecological practices, how that performs economically, but also taking into account social factors such also labor and things further in the value chain. So I think our general approach is that we really focus on this innovations and the transition, agroecological transition, and we focus on co-learning and systems thinking. So what does it mean for the whole system and not just for one practice? And we try to look at the overall sustainability and resilience of the system. The practices that are selected will be tested in experiments later on to see if they really do what we think they do and what's expected by the farmers and other stakeholders. And like I said, we try to bring them to scale by then translating them to the replication labs. And in the Living Lab, we have many participants. So we have the farmers participants, but also the other stakeholders. And in this representative board, for instance, they directly have direct contacts with farmers and other businesses further in the chain. And these people generally do have some decision-making power. They represent governments and NGOs and other businesses. And we very much focus on the participatory activities. That's actually the backbone of the project, is that we do this all in a participatory way. And maybe I can go over to some benefits and challenges like you asked before, Jan. Is that a good idea?
Mm-hmm. Yeah.
Yeah, so the benefits we see is that we really try to make this agroecological innovation work, to work with stakeholders on the ground, to work with the farmers, to have them identify promising practices. So also building on what's already there, and also use the local means that are already available and try to get that further. So we do a lot with participatory activities. That's also really a benefit, the co-creation of methods, that it's not something top-down coming from us, but we develop it together. So that we get an increased connection between all those activities. And also because we're in so much contact, we have regular activities at regular intervals. So there's a continuity of the developments. And it's really benefiting the local actors. And what another thing that is a benefit is that we, at least that's what we try, of course, to co-create a lasting agroecological network, so that once the project is finished, it doesn't stop, but that it's really taken on. And that's also made possible by working so closely with local people. And we try to work on the co-learning and the systems thinking, that if you change something in this, that if you change the ecological practice or a combination, it affects your whole system and not just one, not just soil fertility or just water use efficiency, but it also has links to the chain, to the value chain, to the market, and to what the consumers want. So we hope to create a lasting agroecological network. Well, of course, there are some challenges also, and the challenges is that we've run into so far is to get acceptance and proof of performance. We still have to start the experiments on the agroecological practices, and yeah, that's something. Yeah, we still have to see how that will work, and we want to be sure that people agree, and the interaction with farmers and other actors that really needs attention. And we have a limited budget for experimentation, so we cannot do everything. So we have to choose some of the agroecological practices or combinations, and that also needs to be in good agreement with the farmers. And the framing of what we do is also something that's very important because of how we frame agroecological practices, because we don't want to frame it as a solution for the poor or something like that. I think agroecology is much more. So we really want it as an overall goal, and not just working for the poor. So agroecology is not just a solution for the poor, but it's a general and intrinsic transition that we need. We are struggling a little bit at the moment with, because the project is an EU project, so it's all formulated by researchers with all these research questions. And we struggle a bit with getting it from a research lab to a living lab leader led project. So it tends to be a bit north, south, top down, because we are in this situation. We sometimes are a bit too optimistic, too a bit ambitious as an academic. And this first phase was very intensive to set it up, but it was quite researcher driven, and we are now trying to get it also the other way around and have each living lab has a living lab leader, trying them to get into the lead of developing the living labs further. And another challenge is overcoming mindsets and reality. So get to optimal combinations of agroecological practices, overcome cost and labor constraints that are there at the moment, because of course the farmers speak from their current experiences, and what we would like to go beyond the current limitations, but also see what's possible, and then try to solve practical issues also by looking at institutional and infrastructural developments that are needed to get this transition done at the farm level. I think that's in short. Well, maybe it's not so short, but that's what I want to say so far.
Yeah, thank you very much. Yeah. I can just emphasize what you said. I think, most important, very, very important keyword is acceptance. To accept also, not to come from Europe with our ideas and try to put it through, to accept it, to work on the same level. And I think the best indicator is after the end of the project, does the project continue? Do the people continue with this, with the ideas, or does it stop? I think this is the crucial thing, and we have to ensure that after 3 or 4 years, the people or the acceptance is there, and the people voluntarily or are convinced or motivated to continue with these techniques. And but very good, so very interesting. So Margarita?
Yes, we would like to hear from CANALLS project, Dr. Tesfaye.
Okay, thank you very much for inviting us to just share our experience and knowledge since the project starts. It is almost now 15 months or 15. Now this canal, in fact, I didn't prepare a detailed slide. I have only one slide just because to save the time. So in CANALLS project, CANAL is the agroecological transition, which is implemented in Central and Eastern Africa. And there are 4 case countries, Cameroon, DRC, Rwanda, and Burundi. And so we have tried to define the agroecological living lab under our project context, that it's a kind of a physical space where through cooperation workshop, try to identify or targeted, combined agroecological practices or solutions that can address, complex challenges. And it is once we have once we have already, come to the solutions or proposed solutions or practices, then these solutions will be co-tested at experimental field sites in the farmers' fields, using a multi-methods approach and also a and also facilitating by the multiple stakeholders, which consist of both public, private sectors, and also other stakeholders. And then also address in a specific real life settings. So now, for example, just to give you one example, we have already now proposed to establish 8 living labs, 4 in DRC, 1 in Cameroon, 2 in Burundi, and 1 in Rwanda. So I just want to give you one example in Rwanda, what we have done now since June last year. So the living lab site is called Kamoni. The aim is in this living lab is to transform the agroecological farming system from level 1 to level 3. As you know, I think there are 5 levels under agroecological transitions, which has been suggested by authors like, for example, Glissman. Level 1 is increasing efficiency of input use while reducing the use of environmental damaging inputs. So we'll try to use as much as we can to increase the efficiency of the different agricultural inputs, like, for example, fertilizers, to use more organic fertilizers, and also increase water use efficiency, and also this using also improved seeds or quality seeds, while reducing the over-fertilization and also over-usage of water. And then to reach a level 3, which is redesigning of the agroecological farming systems across landscapes based on the different ecological process. So we are trying now to address some of the relevant elements of the agroecological elements have been suggested by FAO, 10 elements, and also the 13 elements of the 13 principles of HLP. So what we have done until now is, the main activity we have done is, we have done now, just to tell you, for example, the living lab, we have tried to break down into 3 phases. One is the planning phase, the second is the implementation, and the evaluation. So during the planning phase, this is from June to December last year, what we have done is we have tried to identify the potential stakeholders that will be involved in the project. The stakeholders are diverse stakeholders. We have made this through conducted a questionnaire interview, focus group discussion, and we have now come out, tried to establish a multi-actor stakeholder community in each living lab. Now the second phase is now to go to the implementation phase. Now, through the implementation phase, we have conducted co-operation workshops in each country, in each living lab. We have the first co-operation workshop was meant to identify the problems or the challenges, the key challenges in the area where we are going to implement the different practices. So what we have started is, in fact, from a bottom-up approach. We have the proposal, but we need to discuss with the farmers and other stakeholders what are their key challenges. So we have done this participatory interactive workshops, and we have, for example, in Kamoni in Rwanda, we have come out that they have prioritized 2 problems, major problems. One is soil erosion, the other is soil nutrient deficiency. And then in the second workshop, we also invite the different stakeholders, including the farmers, to propose which are the solutions. What are the solutions for these practices, for these problems? So we come out with the different combination of agroecological practices. For example, if you see here, you have the agroforestry plus field trench. These are the kind of trench which will be used along the contour to reduce the erosion, plus also growing fodder, grasses. And other practice will be intercropping cassava with the legumes, and also manure with mineral fertilizers, and also liming, because in some areas there are also problem of acidity, to ameliorate the acidity. So now what we have said is this is in fact one of the working landscape we will work out in this site was called Murabi, agroecological farming site. So we use the different slopes, for example, on the top slope, the back slope, and also on the foot slopes. So we will try to test these different practices that has been proposed by the stakeholders and monitor them, and then finally we'll see the output of these practices. So, so for example, with regard to the participants, you can see the distribution of the participants. We have from farmers organization, cooperatives, value chain actors, governmental institutions, from research, academic, NGOs, and civil society. So we have now 20 members in each living lab. And this will be involved, and the stakeholders will be involved at a different level, at the different stage of the project. When I say this, depending on the capacity of the stakeholders, some of them can be consulted for any feedback. Some of them can also be involved in the field, for example, especially farmers, and some others also can also be collaborating with the living lab at the later stage. And some of them also can only inform them, for example, like the civil society and other things when we have some dissemination materials. So, so this is general, just a very short progress we have made until now on this one of the sites. Now, with regard to the benefits of the living lab, well, what you can say is, in fact, this is an expected benefit or outcomes because of when we start the project, we started from the bottom up by trying to analyze the problems. So this is based on a demand-driven research. So we have already now analyzed the problems, the cause of the problems, and what are also the consequences of the problems. So we have, with the stakeholders, we have come out with the solutions that can at least address these problems. So hopefully we assume that there will be more increased adoption and also upscaling of if the practices are result in a promising way. And the other thing is also, since these stakeholders are also from the different background and interests, and also they have a different experience, we will try to bring their knowledge. So this will also be a co-sharing and co-exchange of the data and information. This is also one benefit that we see. And we also see that there will be also more increasing networking among the stakeholders. And we hope also we have an opportunity for partnering in future projects and also teaming up in other networks. And also the CANALLS project with its own resource can also give trainings to these stakeholders on the targeted trainings. And this also, I think the stakeholders can also benefit here through capacity building. So because this project, in fact, is also building on the existing knowledge and also on the existing projects. So this is what the benefit we see. With regard to the challenges, the main challenges we see up to now is that it's not easy to bring the different stakeholders on board and commit themselves. So this is one of the challenges that we can see. The involvement of stakeholders will not be the same level. Some of them will not be fully committed. So we will have some challenge there, and we'll try to address this by trying to motivate the stakeholders and also make the benefits, especially in kind, what they can get now from them, increasing their knowledge and other capacity building. So there is an high expectation in some of the stakeholders we see. And the other is also, there is also implementation difficulties can also be seen in some of the living labs because there is a lack of knowledge among the stakeholders, also on the, so we need also to build up or increase the knowledge of the stakeholders and also the partners. And the other thing also is, at the end of the project, the sustainability of the living labs is also, we should try to take into consideration from now, because we want to continue this living lab sites and even also upscale it. So we need a kind of bringing the different stakeholders is one of the advantages, that because, for example, like NGOs can also take up some of the project results and continue with the project. We hope so. And so seeking for funding opportunity is also one of the important things. We have to see it from towards the end of the project. So this is in short what I can say about the living lab we have. Still is in developing. It's in progress. Yeah, thank you.
I think it was very interesting to share the different perspectives from of our different projects, CANALLS, NATAE, CIRAWA, PrAEctiCe, and how they are on the ground developing living labs in different conditions, different ecosystems, different crops, different stakeholders. We have, of course, to thank the European Commission for the funding provided under the Farm to Fork Horizon Europe program.